In this lecture, I'm going to try and introduce this formula for calculating moles, which is moles is equal to mass divided by AR or MR. Here, mass refers to the total mass of atoms or molecules or whatever substance you have. And AR or MR is the molar mass of those atoms, or the mass of 1 mole of atoms. That would be called AR. And the mass of 1 mole of molecules, if you're dealing with molecules, that would be referred to as MR, or the molecular mass. So the molar mass is given in the periodic table. So that is simply. So I'm going to tell you what molar mass is, or the mass of 1 mole of atoms. So molar mass, which is the mass of 1 mole of atoms, it's simply the atomic mass expressed in grams. So that is atomic mass expressed in grams. For example, sodium has an atomic mass of 23, which basically means that 1 mole of sodium atoms are going to weigh 23 grams. So I'm going to do a few examples. So sodium, which has an atomic mass of 23, that has a molar mass of 23, or the atomic mass, or the AR, since we're dealing with the atoms, that's 23 grams. If I'm talking about a compound, for example, I'm talking about sodium oxide. Now in this particular case, I have 2 sodiums, so that would be 23. I have a formula unit over here where I have 2 sodiums, so that's 23 into 2, and there is 1 oxygen, so that would be 16. So that would end up giving me a total of 62 grams. So that would be the molecular mass, or the MR, or the molar mass of sodium oxide. And we can do one more example. Let's take the mass of let's figure out the molar mass of calcium carbonate. In this case, you have 1 calcium, which is 40, and you have 1 carbon, which is 12, and you have 3 oxygens. So those 3 oxygens, so let me write this down again. So I have 3 oxygens, so that's 16 into 3, so that's 48, plus 12, that's 60 plus 40, that would be 100 grams. So you can pretty much figure out the AR or the MR of substances by just looking at the periodic table and expressing the molecular mass or the atomic mass, and you just express that in grams, and that would give you the mass of 1 mole of atoms. Now coming back to what our problem is, what we previously studied was that 1 mole of atoms. Now 1 mole is a very large quantity. So if you have 1 mole of atoms or molecules or any substance, so 1 mole of anything has 6.02 into 10 raised to power 23 particles. So that is going to have 6.02 into 10 raised to power 23 particles, which is a very, very large number. And you're not really going to count that many particles. It's impossible to count a number which is this large. 6.02 into 10 raised to power 23 particles means that you would have to count up to a number which has 23 zeros, and that's a very, very large number. Even in everyday life, you're used to counting things, but generally you stop counting things that go into thousands. I mean, it's very hard to count things individually. You can start counting things up to 10. That's very easy. You can count 1, 2, 3, 4, and so on and so forth. 100 is manageable, 500 is manageable, but when things go into thousands, you're not going to count those things. When they go into millions or billions, it's impossible for you to count. It's going to take a very, very long time. So how do people manage to count things without actually counting things? For example, if a bank has to count billions of notes of rupees, it's a very tedious task for a bank. So it has automated machines that do that work for it. But there are other methods that you could use as well for counting things. without actually going into the tedious process of counting them. For example, now you must be wondering why this carton of oranges is drawn on this piece of paper. So now I'm going to explain to you. So you have oranges in a box of carton, and you have to count them. Now these oranges, they're probably around 40 or 50 oranges maximum. So they're not a lot of oranges, but it's going to be a tedious process if you try to count these oranges. The reason is you would have to get them all out and then count them one by one. So that's going to take a lot of time, and that's going to disturb the oranges in the carton, and it's going to disturb all the packing. So how do you manage to count, or approximately count, or figure out how many oranges are there in the carton? You can't do that by looking at the carton, because only the top oranges are visible. You don't know how many oranges lie beneath that top row of oranges. So one method that you could use is, you can figure out, take the total carton and put it on a weighing balance, and you can figure out the total mass of this entire carton with all the oranges in it. And let's assume that the carton itself weighs nothing, or weighs a negligible amount of mass. It has a negligible amount of mass, so you can ignore the mass of the carton itself. So what I've done is, I'm going to try and count. I'm going to try and weigh the total carton. And let's say it comes out to be. It turns out to be 20 kilograms. So the total mass of all these oranges in this carton, that comes out to be 20 kg. So it's a 20 kg carton. Now what I can do is, all these oranges, they pretty much look the same. And if you think of them as atoms, atoms are pretty much very well defined. Even they have slight differences, because we know that certain elements have isotopes. And if carbon has a mass of 1 mole of carbon has a mass of 12 grams, an isotope of carbon can also have a mass of 13 grams. So like atoms and like molecules and like compounds, their masses can differ slightly, very, very slightly. So what you can do is, you can pick a few oranges from the top. Let's pick 3 or 4 oranges, and we can take an average mass of one orange. And let's say the average mass. So let's say the average mass of one orange in this carton. So the average mass of one orange in this carton, it comes out to be 0.5 kg. Now, by simply using masses, I can count the total number of oranges in this particular box of carton to a very high accuracy. And that is that I'm going to take this total mass, which is 20 kg, and I'm going to divide it by 0.5 kg, which is the mass of, which is the average mass of an orange. So if I do that, the answer that I'm going to get is 40, which is going to be approximately or very close to the number of oranges that I have in this particular carton. So I get 40. So this is how you're going to count very, very large things. You're not going to start counting it the hard way by just simply counting numbers. What you would do is, you're going to take the total mass of all the substance. So let's say I have, and I'm going to do some real world and apply the same concept, the same idea, and I'm going to use a sample of a substance. Let's say I have 69 grams of sodium, which has an atomic mass of 23, or a molar mass of 23. Now I know that 1 mole of sodium atom weighs 23 grams. So I'm going to simply use the formulas and figure out how many moles of sodium atoms I have. So I know that the total mass of sodium is 69 grams. And I know that 1 mole of sodium, I'm going to use the formula mass over AR or MR. So 69 grams is the total mass, and I'm going to divide it by the AR, which is 23 in this case, 23 grams, which is my AR in this case, and I'm going to get 3 moles. So you can very easily avoid counting things and use this shorter method of using only masses. So take the total mass and divide it by the mass of the average of an average atom in that sample, and you would get the total moles of a substance. We are now going to start and try and do a few questions to convert a given mass to moles by using the formula moles is equal to mass over AR or MR. So starting with the first one, if you have 10 grams of magnesium and I want to figure out the moles of magnesium, so I'm going to use the formula moles is equal to mass, which over here in this case is given as 10, and I'm going to divide it by the AR of magnesium, which in the periodic table is given out to be 24. And if I use a calculator to figure out what the value is going to be, the calculator gives me this value, which is 0.416, and then there's a long list of 6 which keeps on going on. So one thing that you need to be careful when you're writing answers and doing calculations related to moles, and that is that you must round things up to a minimum accuracy of 3 significant figures. You can't use especially when your answers are irrational numbers, they keep on going after the decimal. So what you can do is you can round them off to 3 significant figures. And what is meant by significant figure is that you're going to look at the first number, you're going to ignore all the zeros and the decimals, and you're going to look at the first number from the left. So that's 1, then there's a second one, and then you're going to round off the third one. So in my case, the answer is going to be 0.4. I'm not going to disturb the second number as well, which is 1, and the third number should be rounded off. And if you look that after the third number you are getting a 6, so that means this 6 should be rounded off to 7. So my answer to this first part is 0.417 moles, and this is the minimum accuracy that is required. Writing more decimal places should not be a problem, but the least or minimum accuracy required is 3 significant figures. So moving on to the second one, again I'm going to use the formula moles is equal to mass over AR or MR. In this case, I have 15 grams, which is my mass, divided by the AR, which for NaCl is going to be, because it's a molecule, so I have to total the atomic masses given for sodium and chlorine, which is 23, plus for chlorine the atomic mass in the periodic table is given as 35.5, and the total MR in this case is going to be 58.5. So it's going to be 15 divided by 58.5, and that gives me, if I use a calculator, that would give me 0.256, and it keeps on going, 4, 1, 0, etc. So the calculator gives me a long answer once again. So I'm going to look at the first number, then the second number, and then I'm going to round off the third number. So after 6 you're getting a 4, which means that your answer is going to be 0.256 moles. MOL would be the unit for moles. Now part C. Part C, you have CuSO4.5H2O and you have 1500 grams. So again the formula moles is equal to mass, which in this case I have 1500 grams, which is equal to 1.5 kg. So I have a lot of CuSO4.5H2O, and this is a hydrated salt, which means that I have to there's one copper in it. So I'm going to figure out the molecular formula first. So copper has a mass of 64, followed by sulfur, which is 32, and then you have 4 oxygens, so that's 16 into 4, and since it's a hydrated salt you have 5 water molecules in it, so that would be 5 into 1 water molecule is H2O, so that's H1 plus another H, which is another 1, plus 16, so that is a total of 18. So I have 5 water molecules. So this is my molecular, the molar mass for the molecule CuSO4.5H2O. So mass over mR, and the answer that I'm going to get is going to be, it's coming out to be, this is part C, so it's coming out to be, I need a calculator for this, so if we can wait 1 second, so it's going to be 1500 divided by 250, and this gives me 6 moles to be exact, and a very precise answer. So you're getting 6 moles for this. The next question is 200 tons of aluminium oxide, and if you want to figure out the number of moles, so you have to convert 200 tons. Now 1 ton has 1000 kg, and 1000 kg has 1000 grams, and this formula moles is equal to mass over AR or MR. It should have all the values in grams. So converting 200 tons, so I would have to first convert that into kg, so I multiplied by 1000, and then I would have to convert those kgs into grams, so I multiplied by 1000 once more. So I'm going to multiply it by 1000 twice, divided by the mR of aluminium oxide. So aluminium is 27 in the periodic table, so there are 2 aluminiums, which is 27 into 2, plus that's 16 into 3. So the total mR, by adding all the atomic masses of aluminium oxide, it's going to be 102. So the answer that I am getting is, it's going to be rounded to 3 significant figures, is 1.96 into 10 raised to the power 6 moles. So my calculator is giving the value in standard form, so there's no harm in writing the value in standard form. So you must follow what your calculator is giving, and that would be fine. The last question is that you have 20 kg of FeSO4. So again, I need to figure out the moles. So I have 20 kg. I need to convert that into grams first. So the total mass is 20 multiplied by 1 kg has 1000 grams. So I'm going to multiply 20 kg by 1000. So that would give the value in grams. And then I'm going to divide this by the mR of FeSO4, which is going to be 56, which is Fe. Plus there's 1 sulfur, that's 32, plus there are 4 oxygen, so that's 16 into 4. And once I do my division, that's going to give me 304,000 moles. So that's around, that's probably a lot of moles. So 20 kg of FeSO4 has a lot of moles, so it's 20,000 divided by the mR. So this is how you're going to find moles. Most of your values are going to be rounded off to a minimum of 3 significant figures. So we're going to do another exercise now. We will now do another exercise to convert moles to mass, and we will use the formula moles is equal to mass divided by mR or AR, the molecular mass, the molar mass of the molecule, or the relative atomic mass or the molar mass of an atom. So AR stands for an atom, the mass of an atom, and mR stands for the mass of the molar mass of a molecule. So we're going to start doing the first question that we will do is, let's try and find out what's the mass of 0.0125 moles of phosphorus. Now we're going to use the formula. We know the moles, which is 0.0125, and we want to find out the mass. So the mass is unknown, and we're going to divide it by the mR or AR of phosphorus. So the AR of phosphorus in the periodic table comes out to be 31. And when we do the calculations, the mass would be 0.0125 moles multiplied by 31, which would be equal to, so our mass in the first question would come out to be, and you're going to use your calculator now, so it's going to come out to be 0.3875 grams. Remember, this formula always gives answers in grams. Let's do another question. So let's say I have 1.8 moles of copper sulfate. Now again, I know how many moles I have, so I'm going to put that in the formula. It's 1.8 moles is equal to mass, which is the unknown, divided by the MR, which we are going to find out from the periodic table. So copper is 64, and we're going to add sulfur, which is 32, and then there are 4 oxygens, so that would be 16 into 4, and that comes out to be, and to find out mass, we need to multiply 1.8 by the MR of copper sulfate. So the mass comes out to be, in this case, it would be 1.8 multiplied by this entire thing. So that comes out to be 288 grams. So that's your second example. Now we're going to move to another example. Let's do question C, which is, let's say you have 0.55 moles of sodium chlorate 5, which is NaCl O3. So I know I have 0.55 moles, and moles is equal to mass divided by the MR. So there's the MR would be the sum of all the atomic masses in the periodic table. So sodium is 23, and I have 1 chlorine, which is in the periodic table is 35.5, and I have 3 oxygens, which is 16 into 3, and I'm going to sum that up. So the mass would be 0.55 multiplied by the sum of all of this, which would be the MR. So it's 0.55 multiplied by MR. So your calculator, do this on your calculator, and it gives you an answer which is equal to 58.575 grams. So that's part C, and let's do one more example. So I'm going to do another question, and this time let's say I have 5 moles of a compound which is CaCO3 dot MgCO3. Now what this dot states is that this entire crystal has 1 CaCO3 compound and 1 MgCO3 compound in 1:1 ratio. So I have 5 moles of this. So I'm going to try and do this calculation. So this would be equal to 5 moles, which is equal to mass divided by the MR, which in this case is going to be 40 plus 12 plus 16 into 3, which is 48, and then I'm going to add magnesium to it. So magnesium is 24, and then there's 1 carbon, so that would be 12, and then I'm going to add 16 multiplied by 3. So that's going to be my MR in this case. So I'm going to take out a calculator to do this specific calculation. So my MR in this case comes out to be, it's 40 plus 12 plus 16 into 3, that's equal to 100. And then I have 48 plus 12, that's 6, and 84. So I have 184. So it's going to be 184 multiplied by 5, which is 920. So my mass in this particular case comes out to be 920 grams. We will now do another exercise to convert moles to mass, and we will use the formula moles is equal to mass divided by MR or AR, the molecular mass, the molar mass of the molecule, or the relative atomic mass or the molar mass of an atom. So AR stands for an atom, the mass of an atom, and MR stands for the mass of the molar mass of a molecule. So we're going to start doing the first question that we will do is, let's try and find out what's the mass of 0.0125 moles of phosphorus. Now we're going to use the formula. We know the moles, which is 0.0125, and we want to find out the mass. So the mass is unknown, and we're going to divide it by the MR or AR of phosphorus. So the AR of phosphorus in the periodic table comes out to be 31. And when we do the calculations, the mass would be 0.0125 moles multiplied by 31, which would be equal to, so our mass in the first question would come out to be, and you're going to use your calculator now, so it's going to come out to be 0.3875 grams. Remember, this formula always gives answers in grams. Let's do another question. So let's say I have 1.8 moles of copper sulfate. Now again, I know how many moles I have, so I'm going to put that in the formula. It's 1.8 moles is equal to mass, which is the unknown, divided by the MR, which we are going to find out from the periodic table. So copper is 64, and we're going to add sulfur, which is 32, and then there are 4 oxygens, so that would be 16 into 4, and that comes out to be, and to find out mass, we need to multiply 1.8 by the MR of copper sulfate. So the mass comes out to be, in this case, it would be 1.8 multiplied by this entire thing. So that comes out to be 288 grams. So that's your second example. Now we're going to move to another example. Let's do question C, which is, let's say you have 0.55 moles of sodium chlorate 5, which is NaClO3. So I know I have 0.55 moles, and moles is equal to mass divided by the MR. So there's the MR would be the sum of all the atomic masses in the periodic table. So sodium is 23, and I have 1 chlorine, which is in the periodic table is 35.5, and I have 3 oxygens, which is 16 into 3, and I'm going to sum that up. So the mass would be 0.55 multiplied by the sum of all of this, which would be the MR. So it's 0.55 multiplied by MR. So your calculator, do this on your calculator, and it gives you an answer which is equal to 58.575 grams. So that's part C, and let's do one more example. So I'm going to do another question, and this time I have, let's say I have 5 moles of a compound which is CaCO3 dot MgCO3. Now what this dot states is that this entire crystal has 1 CaCO3 compound and 1 MgCO3 compound in 1:1 ratio. So I have 5 moles of this. So I'm going to try and do this calculation. So this would be equal to, 5 moles, which is equal to mass divided by the MR, which in this case is going to be 40, plus 12 plus 16 into 3, which is 48, and then I'm going to add magnesium to it. So magnesium is 24, and then there's 1 carbon, so that would be 12, and then I'm going to add 16 multiplied by 3. So that's going to be my MR in this case. So I'm going to take out a calculator to do this specific calculation. So my MR in this case comes out to be, it's 40 plus 12 plus 16 into 3, that's equal to 100. And then I have 48 plus 12, that's 6, and 84. So I have 184. So it's going to be 184 multiplied by 5, which is 920. So my mass in this particular case comes out to be 920 grams. In this lecture, we're going to try and find out AR or MR of a substance by using the formula moles is equal to mass over AR or MR. In this case, we would be given moles and we would be given mass, and we would be asked to find the AR or MR. So let's say, let's do the first question. We have I want to find an AR of a substance, and I need to identify the substance as well. So let's say I have 0.55 moles of that substance. So my moles would be 0.55, and the question has stated the mass as well, which comes out to be 12.65 grams. So what is unknown is that I have a substance whose moles is 0.55 and whose mass, equivalent mass, is 12.65 grams, and the AR is unknown. So you can use the formula and figure out the AR. So if you do the calculation, your AR would be equal to, it would be equal to 12.65 divided by 0.55, and doing this on your calculator, that would give you an answer which would be equal to 23. So now you know the AR of this particular substance, so you go and check in the purity table, and this comes out to be sodium. So sodium has an atomic mass, a relative atomic mass of 23. So this substance comes out to be sodium. Let's do another example, and let's say we are asked to find the MR of a substance, and they've told you that it's calcium carbonate, but you have to prove that it's calcium carbonate. What they've given you is, they've told you that the substance has 25 moles and its equivalent mass is 2500 grams. So moles is equal to mass over MR. So the MR is unknown, and you can find out the MR by rearranging it. So it's going to be 2500 divided by 25, which comes out to be equal to 100, and you were asked to prove that it's calcium carbonate. So if you look at calcium carbonate, and if you look at the purity table, calcium carbonate, the MR of calcium carbonate would be 40 plus 12 plus 16 into 3, and that would come out to be exactly equal to 100.